So in this lesson, let's look at AFC, Automated Frequency Coordination, an important part for standard power operation. So now why do we need AFC? Why do we need to basically coordinate? Because a lot of incumbent services operate in the 6 gigahertz band. So as you can see here, 6 gigahertz band, microwave links is heavily used. So this is the lower part of 6 gigahertz spectrum usage in US, and this is the upper part of the 6 gigahertz for the microwave link use. So that way, whenever you basically operating in outdoor environment, you have to check with these incumbent service providers is your access point can use that frequency without interfering with these links. So how does it works? So FCC basically authorize 13 different kind of operators. They are the one have the information, and they need to basically make sure they all central communication with the FCC approved kind of database, and then they can provide that information to the APs. Whenever the AP come into power operate, they check with these AFC operators. That way Wi-Fi Alliance also being one of the AFC operator, in the mix here, and Google, ComSearch, Sony, many vendors, there are 13 vendors, Broadcom and Qualcomm as well as a chip manufacturer. They also basically willing to basically being the AFC operators. So now how it works basically, in a simple kind of form, let's look at. So before your access point operate in the outdoor environment, it has to basically provide certain detail to your AFC operator. So what are the details? Basically FCC ID of your access point and the AP serial number, and what is the geographic location of your AP. Typically longitude and latitude, and then typically you need to provide height of the AP as well from the ground level, and then certain uncertainty, what we call location uncertainty, to basically AFC operator to work out what is the sort of level your AP can operate. So once you provide this information to the AFC operator, so AFC operator will get back to you with two information: what is the available frequency and the permitted power. So that way, sometime in your scenario, access point maybe directly communicate with the AFC operator, or access point is managed by a controller, either cloud or on-prem. In that way, if it is an on-prem controller, that controller communicate with the AFC operator. In the cloud instances, your cloud portal will communicate with the AFC operator. So this communication is API based. You don't really want to do manual sort of involvement. So this API based communication will go and provide this detail to the AFC operator, and then the AFC operator will work it out, what are the available channel and power level, and provide that information. So once that information come through, you control cloud operation can assign the particular channel to the access point. So now this AFC operator always need to communicate with the regulatory database. In US it is being FCC, that FCC database being basically updated by the incumbent operators. That way, that's where the AFC operators are syncing the data. So important thing to remember is actually what we are trying to do is preventing your Wi-Fi operation impacting the incumbent. In that way, it is the way it operates. So it is not other way around. Your access point channel and power will not being updated anywhere. So it's always basically the other way around. So now, even you basically get a channel and power level, that does not mean you are allowed to use that channel and power forever. So every day you need to basically check that detail. At least once a day, you need to check with the AFC operator, and due to some reason, either AFC operator did not respond, or basically your channel and power level is being basically not allowed anymore, you have to cease your operation. That means if no response coming from the AFC operator, or it give a different kind of channel and power, you have to basically cease your operation. It's like a specified like 11:59 p.m. midnight kind of time frame. You have to basically make the change. So that way now a couple of things basically. So now whenever you're deploying 6 gigahertz outdoor, those AP or your controller, if it's on-prem, they have to communicate with this outside world. In that way, sometime your enablement IPs, should be able to go to these AFC operators. So it's important, just pay attention, because sometimes typically in enterprise today, we completely isolated our subnet. We use private IP subnet. There are no need to go to internet from those IPs. But with the AFC operation, your controller need to communicate with these AFC operators. In the cloud environment, it is always clouds are public cloud. That means typically on the internet, they can communicate with these AFC operators. But specifically, if you have on-prem controllers, keep that in mind. The other thing is basically this operation of if it is not able to communicate, sometimes your 6 gigahertz operation may be stopped at the end of the day or midnight time frame. So some challenges will be there. But the biggest challenge sometimes, if you are deploying these AFC operated APs inside the building, so then how do you basically get a GPS coordinate inside that? Your AP need to have a GPS coordinate. In that way, when you deploy inside the building, do you get a good GPS connection inside? Bit of challenges are there. So these things will be worked through, but in overall, this is how the AFC operation So now with that, probably now let's look at some of the device classes, in the next lesson. It is important to understand this LPI standard power. What are the different client device types being specified.